Morning to all of you.
Good morning, sir.
So last class we have seen deviation for a small angular prism. So what was that equation for it? Praveen.
Delta equals to n minus 1 into a.
Okay, n minus 1. Okay. Now, Chiketa Bhatnagar, what is the lens prism formula? Yesterday we have derived the equation. Rayans Vijay.
Yes, sir. Sir, deviation is equal to I plus E minus A.
Prism formula means refractive index equation.
Oh,
N equal to N equal to anyone?
Sin A plus dm by 2 upon sin A by 2.
Okay, refractive index N equal to sin A plus dm by 2 divided by sin A by 2. So what is the equation for deviation in terms of angle of incidence, angle of emergence, and angle of prism? Anyone?
Deviation is I plus E minus A.
Okay, deviation is I plus E minus A. These are all very, very important points. And there will be a test for you, periodic test. You can see the timetable and the topic portion for the test in your school website. So the topic is ray optics. Okay. So till what portion we will discuss, that much portion will be there. So go through the timing and other things in a school website. So there will be a test for that. So one numerical regarding this, after that we'll go to the next topic. So you can write one numerical based on this. Angular deviation, how to find out angular emergence regarding the prism. Prism is very important topic. First number, you can note the short form. A ray of light strikes one face of the prism. A ray of light strikes one face of the prism at an angle of incidence 60 degree. At an angle of incidence 60 degree. A ray of light strikes one face of the prism at an angle of incidence 60 degree and angle of refraction is 30 degree, 30 degree. And angle of refraction is 30 degree, 30 degree. Full stop. If the angle of prism is 60 degree, if the angle of prism is 60 degree, find the angle of emergence. Find the angle of emergence. Very simple question of 2 marks. The angle of prism is 60 degree, find the angle of emergence. So 2 steps, 2 equations to be used. All of you try. Angle of incidence 60 degree, there only the refraction is 30 degree. Angle of prism is 60 degree and angle of emergence, we are right. Degree angle of incidence and angle of refraction is what angle of refraction. R1 equal to 30 degree. Angle of incidence 60 degree. At that point, R1 is 30 degree. So you have to find out the angle of emergence. Anyone? Afshan Syed? A is 60 degree. I also 60 degree and R1 at that point that degree. And what is the angle of emergence? And here you can mark as R1 and R2. So point number 1 is A is related to R1 and R2 by A equal to R1 plus R2. Value of A is 60 degree. R1 is 30 degree. So what is the value of R2? R2 is equal to 60 minus 30, that is equal to 30 degree. R1 is 30 degree, R2 is 30 degree. Then you should get some striking point in your mind. R1 is equal to R2 only when minimum deviation is possible. That's the condition. So here we see that R1 is equal to R2, both are equal to 30 degree, which means that deviation is possible only when deviation is minimum. So when deviation is minimum, 2 point याद रखना है. One is R1 equal to R2 and I is equal to E. When R1 is equal to R2 that degree, we say that it is only possible when minimum deviation. When it is a minimum deviation, then I is equal to E. Therefore, E is equal to I, value is equal to 6. And log emergence is 60 degree. And 60 degree. So incident ray, refracted ray will be equally inclined and incident ray must be equally inclined and refracted ray will be parallel to the base of the prism. So when it is a minimum deviation, 2 points you have to keep in mind. First one, I is equal to E. When I is equal to E, R1 is also equal to R2. So incident ray, emergent ray are equally inclined to the refracting faces and refracted ray, basically inside the ray is exactly parallel to the base of prism. So this is one question for that. Next point we discuss what is the dispersion of white lights. Next point is the dispersion. Dispersion of white lights. So when white light is passing through the prism, so you can see all the colors are separated. Dispersion means when white light is passing, white light ke andar there are 7 colors. All 7 colors are there. Visible spectrum, visual. When white light is passing through a glass prism, all colors are separated. That splitting of white light into its constituent colors while passing through the prism is known as dispersion of light. Dispersion of light. So dispersion of light. So dispersion means the phenomenon of splitting of a beam of white light into its constituent colors on passing through a prism. So that splitting of white light into its constant colors while passing through prism is known as dispersion of white. You know how to find out deviation, everything, you know what is the meaning of deviation, etc. Suppose this is white light coming in. White light. When white light strikes first surface of the prism, from there only it divides. So from here the division starts. All the colors. Okay, all of the colors will be lying here. 7 colors will cut this. This is the initial direction of incident ray, white light incident. So first color, second, third, fourth, 5, 6, all 7 colors will be available. Then After that, when it reaches the second surface, one more refraction takes place. And after that, they finally come. The one color. The lower one is violet color, the upper one is red color. This is called, all 7 colors will be coming outside. First one, second one, third one, fourth one, fifth one, sixth one. So the lowest bottom, this is called visible spectrum. All 7 colors will be here. The visible spectrum, the bottom is violet color and the top one is red color. That means we see that the violet color is deviating more than the red color. Why we had explained. Where you can mark the deviation. You can mark the deviation. All the colors are undergoing different types of deviation. So deviation equation is not very mysterious. Deviation equal to n minus 1. Deviation n minus 1 in p. So deviation is depending upon refractive index, but refractive index also depends upon wavelength of light. So all different colors, violet, indigo, red, indigo, all the colors, blue, etc. Wavelength different. All are having different wavelengths. All the 7 colors are having different wavelength. Least wavelength is for violet and maximum wavelength is for red. That I am coming to that point. So first I am going to mark what is the deviation produced by violet and red. So you are to extend the red color backward. So this will be the deviation produced for it. And deviation produced for violet color, you can extend. This will be the rate that is going for violet color. From the initial direction. So you can mark this angle as deviation. So violet color deviation is more than the red color. Violet is at the bottom and red is on the top. Why? We have explained this. So you can see violet at bottom side, violet color, and top side, you can see red color. All other colors are lying from the bottom to top picture. All are having different wavelength. So deviation is depending upon the refractive index. Refractive index of a material, whether it is a prism, whether it is a lens, depends upon the wavelength. So n depends on wavelength. Don't think that it will be constant. N depends on wavelength, and this is given by Cauchy's formula. Given by Cauchy's formula. Is n equal to a plus b by lambda square plus c by lambda to the power 4. So this is the equation given by Cauchy's formula, and a plus b by lambda square plus c by lambda to the power 4x. The equation given by him, and here you can see that n is equals to. So for numerical etc., we neglect the other term and we consider common distance. So mainly you have to learn, so there is a numerical in NCERT by this equation n equal to a plus b by lambda square, or at least you have to remember n is equal to proportional to wavelength. If wavelength is less, then refractive index will be more for that color, for that medium, inverse proportion. The exact equation is this is known as Cauchy's formula. A and B are constant, Cauchy's constants. So here we are writing it as n is inversely proportional to wavelength. Now, wavelength of violet color is less than wavelength of red color. Exact values of wavelength of all the colors will be explaining in the chapter electromagnetic waves, where we discuss all types of EM waves, including light, visible light, wavelength. There we learn. Approximately violet is 4000 angstrom and red color is about 7900 angstrom. 8000 angstrom can approximately be. So wavelength of violet is less than red color. Therefore, refractive index of prism for violet color NV का मतलब refractive index of prism for violet color be greater than refractive index of prism for red color. So from equation number 1 you see that, but deviation is directly proportional to refractive index. So we'll find that. So deviation produced for violet color is greater than deviation produced. So when white light is passing through prism, all the colors undergo deviation. That is why they are splitting. Violet is undergoing maximum deviation coming to the bottom, and red undergoes least deviation coming to the top. Okay, so relation is given there. Refractive index of a medium is not at a constant, depends upon the wavelength. Which color is passing? Violet के लिए एक refractive index, red के लिए same material का refractive index अलग हो. So question is n equal to a plus b by lambda square. So when you plot a graph between n and lambda, refractive index and wavelength, inverse proportion graph will be. Okay, we have plotted this graph earlier also. So this is the exact equation n equal to a plus b by lambda square and inversely proportional. Just remember that. N and lambda graph. Thanks. Okay, next point is, so this is your even sodium light. Earlier we used to use what? Sodium vapor lamps, the street lamps. Nowadays it is all sodium vapor lamps are replaced by LED lamps. LED panels are using there because they consume very less power. Power consumption very less, more LED. You can see in all over the state, all electric, that means sodium vapor lamps were replaced by LED lamps because their consumption is very less. Sodium light means it is a yellow color, but there are two wavelengths in that. The higher class you will perform this experiment, and of course in the next chapter, that means way optics will use this value. And there are two wavelengths in this color, yellow color, that is 5890 angstrom, 5896 angstrom. So when sodium yellow light coming from the sodium vapor lamp is allowed to pass through the prism, again it splits into two colors. Two parts are there. If in a combination color is coming, prism will split it because of the same reason. They all colors undergo different deviation. Next point is, what's rainbow? Some preliminary ideas about the rainbow. So what is rainbow and what is the condition for observing rainbow? What are the processes behind it? Rainbow means, so when sunlight is reaching on water droplets in the atmosphere, in that light first as a small water drop acts just like a prism. They disperse the color, and before coming out of the drop, they undergo total non-reflection and ordinary refraction. So in this way, rainbow is formed. So it is dispersion of sunlight by water drops in the atmosphere. This phenomenon is due to combined effect of 3 points you remember. First is dispersion of light, total non-reflection, and ordinary refraction. Because of the combined effect of these three, we are getting the rainbow formation. So this is of sunlight by spherical water droplets of rain. So condition is there should be water droplets in the atmosphere. So during a rain shower or just after that, we can observe the rainbow. So what are the conditions for observing rainbow? First thing is that the observer backside should be toward the sun. That is, the sunlight is coming from your behind, and that will be reaching on water droplet that is in front of you. Then this process will take place, then we can see the rainbow. So the condition for observing rainbow are that the sun should be shining in one part of the sky. Example, if it is western horizon while it is raining in the opposite part of the sky, that is a eastern horizon. So an observer can therefore see a rainbow only when its backside is toward the sun. At this point, you have to remember what is the condition. The observer backside should be toward the sun. The right ray should come behind and should fall. Okay. And should come in front. And this kind of effect will be taking place. What are the three different processes taking place? One is dispersion, total internal reflection, and refraction. Afshan, tell me what are the three types of process that is taking place or responsible for rainbow formation?
Dispersion, TIR, total internal reflection, and refraction.
Parth Sharma.
So, dispersion, total internal reflection, and refraction.
Okay. So three processes. First one is dispersion, TIR, and refraction. So there are two rainbows are there usually. One is a primary rainbow and the second one is called secondary rainbow. There are two rainbows. First one primary rainbow and the second one is secondary rainbow. In the primary rainbow, inner one is violet, outer one is red color. Inner bow is violet and outer one is red color, and they can be observed to an angle of 40 degree to 42 degree from the direction of incident sunlight. Secondary rainbow. Inner one is red, outside one is violet. And they can be observed approximately an angle of 50 to 52 degree from the initial direction. And primary rainbow is brighter one. Its intensity is good one, and secondary rainbow is comparative brightness is less bright. The brightness is less brightness. Primary rainbow is formed by one dispersion, one TIR, and one refraction. Secondary rainbow is formed due to one dispersion and two TIR, two total and reflection and refraction. So these are the main classification, and one diagram I am going to mark for that. How dispersion is taking place, TIR is taking place, and ordinary refraction is taking place from a single water drop. We require only preliminary points and values. Water drop. You know, you can calculate the critical angle for water to air interface. We don't know how to calculate. Suppose the sunlight is entering this is your sunlight. Striking on water drop. As soon as it reaches there, it divides. Violet and red. Dispersion is taking place. Now it is trying to come from water to air. So now from here it is water to air. The I will be greater than 55, so PAR is taking place from here. Total internal reflection, this is PAR. At this point, PAR will take place. After undergoing PAR, they will be coming here. All these colors. After that, they will be observed like this. So you will be getting violet and red at an angle of 40 to 42 degree from the initial direction of sunlight. So this is rainbow formation. This diagram is enough. Only one diagram is enough. So ordinary dispersion takes place. PAR and ordinary refraction, and rays are going to observer eye, and with the initial direction we mark the angle. So 40 degree to 42 degree, violet is 40 degree and 40 degree we get red color. So this is about the rainbow formation. Only preliminary ideas are required for that. So up to this much topic, there will be a test for you. Okay, that is coming days. You can see School website for the time and date for the test. The topic is ray optics up to here. Next small part is we are remaining with optical instruments. Optical instrument.
Sir,
Anything? Anyone want to ask something?
sir,
Speak loudly. Yeah.
sir, it is all subject test.
All subjects are there. You just see the website, no? The periodic test timetable is given there. Okay.
No, sir, today is mock test. Today is mock test.
That is today's mock test. That is just for a practice.
Okay.
Okay, that is a CBS as per CBS instruction. To aware, we have to practice the system. So other test timetable is already given there. You can go to that. All the subjects are there. Prepare properly. Go through the
Sir?
site and see the timetable for that. Yeah. Any other question?
So reflection part is removed, so we have to prepare for that also.
Reflection.
Yes, sir.
Mirror, there is no need to learn. For your board exam, there may not be any question from the reflection. But for other types of examination, there will be. Only this year it is, okay, not there. For board examination, you may not get any question from the mirror. Okay. So mirror equation, what is the reflection in mirror? So that part you don't learn. So even I am not giving question from the mirror. Refraction onwards, that you learn from.
Okay, thank you, sir.
Okay, any other point? So only up to here you have to learn. Learn thoroughly. Such practice and learn numericals and all the things. So we have to start with optical instruments. Very, very important optical instruments. Simple microscope is there, compound microscope, and telescope. We usually use astronomical telescope. And one small topic is deleted. Okay, one more topic is here, scattering of light, etc. That is already deleted for this year. And the resolving power of microscope and telescope, that is also not included for this year CBSE. So from left and right, they cut some portion. Some chapters, okay, it is they're beneficial. There are certain chapters that toward the end, last topics are removed. So that point will continue then next class. Anything to clarify? All of you go through the website and see the timetable. Okay, you are having the mock test today, so do that. Other test will continue from the next class. Okay, 1 minute. I am checking your. Pending, if you want to ask, you can ask. Any confusion?
So we have to submit any assignment on 1st August on Saturday.
Saturday.
Yes, so many teachers are telling that the starting time, whatever they have given on the website, we have to submit
That
it.
means
So in
you will be
physics,
getting other information on the way, where to submit and all the things. Okay.
so then what we have to submit in physics?
Separate papers will be there, and so you will be given where to. Okay, destination you will be getting. Don't worry about that. That is on the way. All will be published. Not now. So now today you may be given. That means some website for giving your mock test results. Okay.
No,
On the way
sir.
you'll get. Don't worry about this.
So the question is, sir, on the month of April, sir, you gave the assignment on electric dipole, sir. So do we have to?
No. That is not there. So that chapter is, that part is not there. No board examination. You see in the board examination that is not there. There no electric force. No electric force. Electric force part is not there.
Okay,
And
so there is
electric field is also not there. But without knowing then, how can you go for what do you call it as a course of stream? You can see that. So that part, the question may not be there, but understanding purpose you have to learn that. Without knowing electric field and electric field lines, So you cannot understand electric flux. तो ये भी चीज होता है, तो वहां से क्वेश्चन तो नहीं आएंगे, बट अंडरस्टैंडिंग पार्ट के लिए सब बच्चों को पढ़ना ही है। बोर्ड वैसे जस्ट किया है। ओके, थैंक यू देन।
Thank you, sir.
Thank you, sir.